Hey guys, welcome to the channel. I'm George Lega, and in this video we're going to be going over this personal project that I created. We're going to be going over some of the techniques used into creating an effect like this, and I think it's really useful for motion designers to learn kind of what the tools are and what the capabilities are within Houdini. Cinema 4D has been dominant in motion design, and I feel like Houdini is a really strong tool as well. So those that are on the fence about trying it out, hopefully this will kind of shine some light on how to create some of these effects. Thank you again for tuning in, and we'll get to the video. So every one of my projects starts with a mood board. These are all just images that were taken from Google. Some of them were screenshots that I pasted in there. But the purpose of creating mood boards is to just clarify your creative vision. Usually you don't have kind of like an idea of what you want to create right away. This helps you not jump into 3D right away and then you're kind of just endlessly creating different things. So this kind of really just sets the tone when you start creating your style frames. Sometimes all these ideas on their own, they have their own thing going on. But when you have all these things together in one mood board, it could actually just inspire new creativity. This would be like the really good starting point to start creating style frames. So at this point, you know, I pulled some of the existing controllers that were in the PS5 kind of campaigns. They had some billboard stuff, and I like the kind of the blue gradient, but I wanted to change it into like this kind of red tone, a little darker. I like some of this photography with the rim lighting. I wanted to incorporate something with Venom. Yeah, this is kind of my starting point. Some of these images were pulled a little bit later in the process. So it's just a process that I like to do, and I think most motion designers should do, is first create a mood board where you could set the tone, clarify your vision of what you want to create, and that would be a good building point for the style frames. This was the commercial that kind of sparked a lot of ideas for me. So I don't know which campaign this was for or when this came out, but it has a lot of these transformation kind of effects. And I figured maybe we can create something like that. That's kind of cool. All this stuff looks like it's procedurally done. I could imagine it could be either Houdini or maybe some of the Cinema 4D stuff. But yeah, this was an interesting kind of commercial that has like a lot of variety of different effects and different variations. So like you could see like how they do this whole wraparound kind of a fall off effect. What I'm going to be showing you is kind of like what can drive those effects. So pretty much we're going to be creating fall offs of different kinds using solvers, using Pyro, using MOPs, using VOPs. There's a lot of different ways that you can do these kind of effects. Yeah, once you know like what is the thing that drives these effects, things get a little bit easier in Houdini. We'll jump on and take a look at the project. So here we are in Houdini. We have our first object import. We have the controller here, and then we have a second object that we're going to be transforming. You may not have noticed, but in the video, we go from the original controller that doesn't have the triggers and all that stuff. And then we go into the premium, the Edge controller, the DualSense Edge that has these triggers, that has the little paddles in the back. And yeah, it's just a small kind of difference, but the main thing was going to be the skin of the transformation into the Venom kind of style. So usually when you import FBX files from any source, I always find that they never come in the right size in Houdini. We usually have to transform them down. It's usually 0.01, but it was kind of small. At that scale, I just put 0.02. So we got the controller here. The next thing we want to do is set groups for the shaders that have been placed on the FBX. When the objects come in, usually we have shaders and things like that. In this case, for this object, we don't have any of that. So what we want to do is split them into groups by the primitives. So if we select, for example, double click here, double click there, these are all different selectable pieces. So if we just click on one, it's just going to select the polygon. If we double click here, we want all these kind of split into different pieces in groups so we could assign shaders to them. The first thing you can do is get a connectivity. And in connectivity, we have an attribute called class. That's the one that usually it comes with. We set the type to string if it's an integer. And then for prefix, we're just going to add whatever you want to be letters or words before. And then the next node is where all the work gets done, which is the groups from name node. Doesn't have a icon or anything, but if you go there, now we can put our attribute, which we got from the connectivity called class. So the group prefix, you can put whatever you want, and then you can add a star for it to count up. So now if we middle mouse click, we can see that we have the name of our group, we have the OBJ that we got from the connectivity, and we have the number counting up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then the match size is just to center it in place. Transform to rotate it similar to the other controller. And then in here, we're creating this other group. In this case, I needed to create a group because these buttons in the PS5 have a glass kind of shader in front of it. So that's that. And then these are the top buttons here that for some reason they weren't assigned correctly, and I needed to create that. Whatever groups don't get created the way you want them, you will just create groups for them so you could assign them later. These were just, I guess, I was messing around with some transforms, disconnected those, so those are not working how I wanted. This edges group, I'm not sure what this is. I might not be using that, but I'll just leave it on. And that's our first pass at the controller prep. So the second one, select it, hit space G, we can get into center frame, and we translate it, scale it down. Same thing here. We got the class, we put it into groups from name, and you can see this one has a lot more. This one is broken into a lot of pieces. If we click on something here, you could see this is broken up into more pieces. And that's the reason why there's so many groups being created. So same thing, match size, rotated it. This is a link from Transform 5. So the way you do the link, so to create the link copy is Control Shift Alt, select it, drag it, you get your reference copy. All right. And then same thing here. I started creating the different groups. This one's not selected. Let me see. There it is. Okay. So middle glass. We got this one here on the sides. We got the back, the buttons. So all the different groups that you want to set up. All right. And that's it for the prep of the object. So whichever object you may have, and if you're importing from FBX, you may want to use some of these techniques to break them up into pieces so that when you create the groups, the primitive groups for them, you can import them into Solaris much easier. So here's the setups for how we can create all these kind of effects. First of all, we can either do a non-simulated approach or we could do a simulated approach. Usually I prefer a non-simulated approach, mainly because when rendering, you don't have to wait for the frames to be calculated, the frames before. So you could go skip in between the timeline. Usually you don't need to cache any of the data, so you could render it in different machines. They could be rendering different frames and everything will look as planned. So to get started, we'll start with the non-simulated and then we'll go into simulated. And the first approach that I would take usually would be with VOPs. So if we deep dive inside, and in here we have the controller that I imported. Then here's the other controller. Then I'm subdividing it just because I want a little bit more resolution. That way when we do our gradation map wiping across, we can see a lot more resolution and more detail. So the first thing you're going to create is an attribute VOP. So in here, I already have an attribute VOP created, but I'm going to walk you through how I created this. So I have it keyframed right here on the translate with a $F and then dividing it by 200. Otherwise it's too fast. So that's just, you know, your time, your frames divided by that. So this is what that effect that we're going to do. And the reason why we want to do these kind of effects is because once we can differentiate between the black and the white, we can remap any attributes that we want. We could have it emit particles on a certain attribute, whether it's the black or the white, or we can use an alpha. That way we can have things disappear and appear. We can also use it as a point of distortion. So when it goes to a certain color, we can have that geometry distort as well. So these are all just different things that you would want to do, but they're all driven through the same gradation system. So the way we go about creating this is we first create an attribute VOP. And then the first thing we're going to do is add a ramp. This is kind of like I'm just laying out the nodes so we can start connecting them. The ramp doesn't work real time here, so we'll have to jump back out and then we can kind of see what's happening there. So there you go. We got our split ramp in here. So how do we add noise here? We can get maybe a turbulent noise and put it in here. That didn't work because we have it on type. It's supposed to be on position and nothing happens. So in order for this to work, we're going to have to go and create an add node. We're going to add the current position and then add the turbulent noise, and then we're going to remap it. So now we can see that we have some noise in here. So how do we create a control so it can wipe from left to right? Well, for that, what we're going to do is create a transform matrix, and we're going to put it into position. And instead of, so like this, it doesn't work because we have to do it before the ramp. So we'll create our transform matrix and we'll put it in between our add and our ramp. Now we could see it wipe from left to right. And then the other thing we could do is add another add, connect our transform to matrix to the add, and now we can have it like this. So that kind of cleans it up a little bit. So if we go back to our turbulence, lower the frequency, and now if we go to our transform, we can see we got the wipe from left to right. So we got the turbulent noise that's adding the current position. Then we have the transform, and then we got the ramp to ramp the colors. So again, it doesn't work inside of VOPs. We have to jump back up. Okay, so that's our initial noise. So that's our initial fall off. So how do we get the attributes to come here on the outside? So we'll go dive inside, and what we want is to get some of these attributes from the turbulent noise and some attributes from the transform matrix. So what you need to do is middle click, promote parameter, middle click, promote parameter, promote parameter, and you do this for all the settings that you want to tweak outside of the node. So we'll get transform, we'll get the rotation, scale, and now if we jump out, we kind of have our settings. So here we have our position. So we put $F, nothing happens. So we'll go $F and 200. So it starts off too early. What we can do is we go in here promote parameter. And then we'll put like -1. So now maybe a little lower. Let's see, -0.1, -0.5, 0.7, 7.5. So now we have it kind of building across. We can speed it up and put maybe 150 on the translate. If we play that back, now we can see our noise. Our noise is currently traveling and moving at the same time. So if you wanted to create a static noise object, so it's just like a static wipe, all you need to do is switch the nodes. So we can duplicate the nodes, we'll switch it here, and we'll remove these two here. We'll create our own turbulent noise, and we'll actually put it last, and then the transform matrix, we'll put it first. So we'll just promote this transform here for now. So we'll put the same as here. And now you can see it is static. It's not moving. So you got your own custom noise that you want, but it's not moving. Honestly, I like it when it's moving. I prefer it the other way. I like it how it moves. So we'll switch back here. We'll bring back our original setup. So if we wanted just to create an edge, all we need to do is create another point on the ramp and just color it black. And then we got our gradient here. So most of the time you're outputting this to the color, but you may want to put a different name for the color. If you want to store that attribute, you could create a bind export, and then we can export this color attribute here, and we can call it mask. So now if we look at our attributes, create a new one for the fall off, we create a color, we have our mask here, and now we can see that attribute. So if I pin this and I go back in here, we don't see that attribute there. So we can connect it, and now we have a custom attribute that's not messing with our color attribute. So we got our mask, and let's say we wanted to not use the mask and then do something more simple, right? We can reset it to here, and then we could put mask 2. So now if we look at our color here, we could put mask 2, and we could take a look at that. So we'll put ramp 2. So that's the different attribute there. So let's say we wanted to do even another effect, right? We can do ramp 3. Sorry, this would be ramp 1. We're just using the same ramp, and then ramp 3, and then we're binding. And we can put mask 3. So now 3 is, let's go in here. So what we're seeing right now, it's the output. So we want to see the output for this one here. And maybe this is like a very thin edge, right? And all those are being driven by the same effect here. So if we check our visualizer here, we can go to the fall off, and now we can see mask 2, mask 3, mask 1. Right now we have color under mask 3, so you can go in here and just bring that there. So this is just a control that you can get. So then when you want to create displacements or alphas or emit points from there, this is the way that you can do it. For example, if I wanted to scatter some points, we can see the colors here, and then inside of the density we can put CD, and now we just get points on here. So we can use a copy to points, get our sphere that we can copy. We got our points here, and we could put an attribute wrangle, and we're gonna mess with the scale of it. So for scale, it's $pscale is equal to at CD. So now when they're black, they're at 0 scale, and then you have kind of this effect going on. So yeah, that's one way to do it. You can maybe add another transform, right? You could swap out your object for a box. And then if you don't want it to go crazy, you can get a attribute wrangle. Orient is equal to at p.y. And now everything is straight. Yeah, so that's one way to create those effects. And so we'll just keep moving forward here. So this is our original fall off, and then we have our settings here. We got all of our different things, and we got the attribute blur, which is blurring color, and then in here we have a remap of this effect here. What we do here is we get the color, and then we get the ramp, and then we put it back to C. So connect CD to the ramp and back out to CD. And then you could put a bind export to get the different attributes there. So as you can see, it still follows the original animation from this setup. So if I plug in this guy here, now we can see this edge is actually working in a different way. Then in this one, this is kind of like a tester of how it would look displaced. So if we connect this here, we're actually displacing by the normal. So the way you would do that is go inside here, grab the node that's called displace along normal. We get our color attribute and we put it into the amount of the displace along normal. And then position goes into N here, the vector normal. If we put it to position, it goes crazy here. So we'll put it into N, and then we go back out from displace P to P. And we could also connect displace normal to the normal, get these kind of artifacts there. And that's how that kind of works. So if we think this is like too harsh here, we can just get fall off here, give it more gradation. All right, so then the other thing you can do is in here. So I had showed you earlier that we can use CD for right here, or the mask. And if you want to not do that kind of jittery emission as the mask goes around, you can just turn that off, have the points always there. And with the pscale, that's how we'll be able to stabilize those points. So this is what the effect looks like. It's a lot more stable. And then if we were to do it with the mask or CD, and in this case, we can lower the points. We don't need that many because it's actually concentrating all the points now. So it might just look fine. Let's see. Let's try to do 2000. Yeah, so what's happening is that depending on the surface area that we have white, it's continuously spreading the same amount of points. And that's why it's causing this kind of jitter effect. Just to combat that, you can just leave the points on all the time. So in this case, having copies of objects, it's not going to work. It'll be better the other way, where it's more stable. But this using this technique where you can have the actual amount to be constant, it could be good for like particle emission. So if you're emitting particles, that could be something else. We're going to take a look at attribute transfer. So attribute transfer is pretty simple. It's pretty straightforward. So we got the object here, which is our control. We have a sphere that we're going to animate. And then we have color. So we have black for the sphere. And we got white for the controller. So when we drop down an attribute transfer, our controller gets to black. And then what we need to do is bring in the color. And under conditions, we can lower the distance threshold, and then we can see how that affects. So this is a different type of spread. And now we can get our sphere and we can move it. And that's how it gets affected. All right, so that's what I did here. Then we blurred it. And then we did the same thing with the displacement of the normal. Yeah, this one was pretty straightforward. VOPs is a little bit more intuitive, a little bit more complex. This one's pretty straightforward. And then again, you can get your attribute VOP. We get our color. So we get the ramp parameter. We get the CD. Connect CD back out. So we'll connect it instead to attribute blur. And then I can make this black. And then we have the edge on there. So we could put our interpolation to Bezier, just have a smoother fall off. All right, so that's the attribute transfer. And now if we check out MOPs, we could see we have a similar kind of effect here, and it's wiping across. But now we have a more intuitive kind of interface for the gradient maps for our fall off effects. So we got a shape section here where we could change the type of fall off type to spherical, box, all these different kinds. We got our transforms where we can move them around. We have keyframes here. So from this area to here. We have a guide where we can actually move that. And in this part here, if you have multiple fall off effects, you can multiply them kind of like in Photoshop, where you can add, subtract, multiply, divide, screen, overlay, all these different types. So if you can stack up some of the fall offs, this will kind of work with it. So we have it on set, and that's fine. Then there's the noise section where you can add noise. If we have it like this, it's how we had it originally in our VOP setup, where it's just the ramp. And if we add our noise, we're adding that kind of turbulent noise, and inside there we have all these different types of noises and all the settings there. We can do a remapping, so that way we can flip things around or kind of move the color. So if we go to these settings here on the side, we can flip it, the noise, and then remap actually flips the color. So if we flip here, right here, we have to make sure that we have fit checked, and then we can flip it. And then fall off preview is really just a colorization thing. So we can do the regular gradient, or we can start choosing different types. And you could imagine you can use these as like emission color or different ways that you can use shaders with it. So right here, we'll reset it to what we had it here in the middle. And that's pretty much the MOPs shape fall off. It's just pretty much what we were doing in VOPs, but on steroids. Yeah, it's really good. I would definitely recommend you guys installing that. And if you wanted more features, you could actually purchase the MOPs Plus, which is also great. Has a bunch of different things for motion design and typography and a couple other things there that are really great. The next one is the MOPs object fall off, which is kind of like the attribute transfer that we talked about. And we have our object in the second input, and that's what's going to be influencing our gradient. Yeah, it's pretty much kind of the same idea. We're just scaling the sphere here. We have the same settings in the fall off here. So if we go object, we can see we got a couple different things under object. This is kind of like flipping it over, outside, inside. So this would be like the edge, I guess. This is the radius of that edge. So if we turn it off, the noise, we can see. So surface distance. So you can do an edge like that. You can have your geometry in different ways. So if you do a mountain right underneath here, you can distort that edge. And do a different type of wipe. Volume sample, haven't really used that one, and I haven't really used the point cloud. I just keep it to outside, it's simple enough. And then we have the noise, we have the remap, and we have the falloff preview. And all these falloff nodes have the same kind of parameters. So if we go into MOPs Falloff, there's an audio one, there's a combined, there's falloff from attributes. There's so many different cool falloffs that you can create cool effects with. I definitely would recommend you guys check this out, because this is an essential tool for motion designers in Houdini. So moving forward here, we have the Pyro Source Spread in the simulated section. And if we click on that, we have the object being imported. We're creating a group here called active, which is going to be these two sections here. And here I am creating an attribute overall for all the points. And this is going to be temperature equals to 0 at temperature equals to 0. And then the next one, we're going to create a temperature equals to 1, but we're going to select our active group, which is the points that are selected here in this group. So when we create the Pyro Source Spread node, so right here, so none, we can't see anything. We could see the total burn, the temperature, burn, fuel, diffusion. So if we click on temperature here, we can see where our points were selected here from here. And this pretty much takes care of the rest. If we go to temperature, we go to diffusion, we could see the rate, the search radius. So if we lower this, if we lower the points, all this is going to affect the speed of how this spreads across your object. So that was pretty quick. We can do the rate like maybe slower. So you can see that this section here was not selected. So we just probably need more points here. We could put 60. We'll reset it because it's a simulation. And now it's being taken over. So there's just max neighbors. It's the amount of points that it's going to search. So the more points here, the more it samples the spread of the search for the diffusion. And then if we go to burn, we can have that there. We could go to temperature here. So instead of, so now our attribute is not CD, or now our attribute's not CD, so we're using temperature. So we created temperature, and that's what we want to blur. So in attribute blur, we create the temperature in here. So right now we're on burn. So if we go to temperature, we could see that that's blurred. All right. And then in this attribute wrangle, we're actually making at CD is equal to temperature. And now we can go into our point VOP and remap our ramp into color. That's this color. So if we want to see it, we got to go to the Pyro Source Spread and put none. And now we could see what we did. So right now we don't have anything for CD. And in the attribute wrangle, we're converting CD to equal to temperature. And there you go. And then we have here point VOP. So then we can remap it how we want. So linear always creates this weird, super sharp edge. So we can go to Bezier, and now it's a little bit smoother. And we can also subdivide our geometry. And we could see that kind of ripple effect that the Pyro Source Spread node does, which is great. And you could use this as like particles, like maybe they're burning something. This is kind of what you can do. So you could change the shader as this ripple goes across, and you can add emission that's on the white that emits flames. Yeah, really cool stuff that you can do. So we got our just displacement that you already know how to set up. And now let's jump onto the solver. So we're inside our solver and we have our object. We have it as black. We added a point here in the middle. We have it as white, and our attribute transfer that's going to be taking care of this. So our solver is going to start at this point, and then it's going to multiply across and it's going to spread, kind of like the Pyro Source Spread, but a little bit more simple. So if we go in here, we created our solver. Let's create one from scratch. So we'll create an attribute VOP, and we'll select the first input, and the previous frame to the second input. We'll connect these two here, and let's dive inside. The next thing you need is a point cloud open. And we connect P to the P, and then we have op input 2, which is our previous frame, and put frame on file. Then the next thing we need is to filter through the color. So we'll get the PC filter, and instead of the channel being P, we put CD. We connect the handle here, and then the next thing we do is a maximum, and we'll connect our PC filter here, and we'll connect our color in here, and then we'll put our maximum to CD. All right, so let's see what happens here. So you could see like it spread and it kind of stopped. You want to multiply that, so then that way it spreads a little bit faster. So if we go back inside, right after the PC filter, we could add a multiply constant, and we could put 2 on there. Now if we go back, reset simulation, and now we could see the spread here. So we have the spread here, and you could see that there's like some values here that are being like really black here. So if we go on to CD, we can see that we have like numbers like 8. So we don't want that. So in order to fix that issue, we will go into the end of our setup here, and we'll create a clamp. And then this brings the numbers back down to a reasonable level. So it's from 0 to 1. So without it, it goes into like way high values that we don't want. So just put the clamp in there. And if we go back one more time, let's rewind it, reset simulation. Now we can see it spread around. These parts are not being finished through the spread, and that has to do with the point cloud open. It doesn't have enough points. So if we go to the point cloud open, we select the number of points. We put 60, kind of like we did before with the Pyro Source Spread, and press play now. Oh, we got to go back. So VOPs, we always got to go a level up in order to see our result. So reset simulation, and now we could see it wrap around. And that's it for that solver setup. And then in here, we can create the same thing we did before, is color, ramp, and back out to color. and we can remap it here. That's what we did. And then attribute blur, and then we displaced it. So that's pretty much it as far as the effect. All right, and let's go back and let's go into MOPs Spread Falloff. So which is our last node that we're going to talk about before we get into rendering. And in here we have the object imported in there. We created a group from boundary. So the way you do this is you create a group from attribute boundary, throw it in there. We'll create an edge group, and group type will be points, and we're going to select everything in here. We'll put a star on it. Now if we take a look, we could see that our edges are being detected, and we got the edge group. Then we're going to jump into MOPs Spread Falloff, go in there, and in our starting points we select that edge group. Great. And then in animation we have the spread to $F divided by 150, and now we can see the spread coming from there. So this is all just pertaining to the starting points. So you can add any type of group. So in here, if we turn this off, turn this one on, I created a group here where our points are being selected in different places here. We can just click here and maybe these two parts here. So that's called edge group. And then our starting points on the MOP spread is going to be edge group. So now it starts from those points. So we can just have different groups, and now we go back to our regular edge boundary, or we go through this side here. Then we have the attribute blur and our displacement, just, you know, to see what kind of effect it's doing. So the MOP spread falloff is just like the shapes falloff, only that we're adding this group mask, which you select points through a group, or point cloud, which I haven't really used, or attribute, but yeah, you can just select those different types. So you could create group or attribute. So let's see if this works with MOPs Falloff. So it's using MOPs Falloff as the attribute, and if we create a shape, MOP shape Falloff, we'll go to our shape, scale it down, 90 on here. Let's take a look at the Falloff, and we'll create a gray grayscale, and let's move it here. Let's see. And we'll create points. Okay, so it's doing it the opposite way. So we'll go in here, right there. And it's working with MOPs Falloff. So that's kind of cool. So that's how that works. So if you wanted to create an attribute or your own custom attribute, you can start from there and just make sure that they're points, and then group mask. And then the same stuff is here. The noise, remap, and falloff preview, and then animate is just a spread, and then search radius and max connections. So all these things are gonna change the speed of how the spread goes around. And then cost is like another attribute that you can do to kind of break up the way it spreads. So if you put cost throughout different types of points, it's going to affect the speed in a different way. So in here, let's undo this, and then we'll go group boundaries again. So we have our edge kind of effect, and then we have our displace. So that's how this one works. And yeah, all of these kind of effects are kind of silly right now, but just think about how you can use them in your own projects with your own objects, and how can you create more interesting transformations or like reveals for different things. And this one's just another kind of setup, same kind of thing, but we're connecting our spread through the second input. So instead of using points, we're using the curve here. So if we turn this off here, we have our grid, we have our subdivide, and then MOPs. Right now it's just using the points from the curve. So if we create a scatter, now we could see that that's going on. And you could also do like a resample instead of a scatter, you know, for it to be just a little different. And we're blurring that attribute and we're displacing it. Awesome. So yeah, that's how we created two different types of approaches of how we can create effects of all different kinds through a non-simulated setup and a simulated setup. In the next video, we're going to be going over how we can bring this all into Solaris, how we can use some of these attributes to drive alpha channels and displacement and things like that. So if you found this video useful, just be sure to subscribe so that way you can be alerted when the next video comes out. And thanks again for watching, and I'll see you guys on the next video.